See Lindelof videos, product rule essentials. The question is today, when do I use the product rule? How do I use the product rule? Start with, when do I use the product rule? My whole point to this, when I've done this is my third video tonight on the same subject, because people keep screwing this up. Teachers and professors specifically, much more than students. Students want to know, when do I use this? Not just how. So some professors are suggesting this. Let this be our first equation. Let this be a second equation that we're just going to look at just for a second. And that's the equation says that we have 5x squared times x squared plus 3. And the professors and teachers are saying to students, look, this is a product rule problem because this is a function and this is a function and they're being multiplied. Therefore, this is product rule. And I'm suggesting to you, as people who really need to be able to use this in an applicable way, is that you have to look. This is a sum and difference problem, isn't it? Because hopefully we can agree that we would just do this, wouldn't we? Why wouldn't we do this? This is absolutely ridiculous that we would turn this into product rule. We just multiply this. We get 5x to the fourth plus 15x squared. And then we'd use sum and difference. We'd be done with this in less time than it took us to set it up for the product rule. So this is not a good application of the product rule. So I'm asking you to mark that down in your essential knowledge that have to ask yourself, what rule should I use? Not just what rule can you use. So here we go. That was the end of my sermon. I apologize sincerely. If you look at this, we have 2x times ln x. Let's look at this for a second. We have 2x ln x. We can't multiply this. We can't simplify this anymore. We know that here inside these parentheses is called the argument, right? And you can't do 2x times that x in there and get 2x squared. That's not what this is. This is ln of that argument times 2 times whatever the x value is. Totally different. This cannot be simplified. So you look and you're like, I have multiplication of functions that can't be simplified further. That is when it's essential to know the product rule. So here's what the product rule says. The product rule says that d dx of a function that's composite of one function times the other one is equal to the first function times the derivative of the second function plus the second function times the derivative of the first, or vice versa. It doesn't matter. Like I hear teachers, they get all hung up and it's like, no, this one has to go first. It doesn't matter. And if they say, why doesn't it matter? The answer to that question is 2 plus 5 is 7. 5 plus 2 is 7. We have commutative property of addition. As long as you have function derivative, other function, other derivative, you're in the money, everything is going to be cool. So don't sweat that too hard. Okay, let's move on quickly. So I'm going to do, this is how I do all of my calculus. I just build lists because it's methodical. It's a way not to make stupid screw-ups. I'm going to call this function f of x here, and I'm going to call this second function g of x. So I'm going to say f of x is 2x, because this is the function I'm dealing with, is 2x. And the first derivative of 2x, right? I'm building this piece, and, I'm building this piece and this piece, right? So I'm getting these here. And the first derivative of 2x is simply 2, isn't it? And then I need a g of x, and I need a g prime at x. So g of x, looking at the original function, is ln x, right? So I got my ln x there. And what's the first derivative of ln of x? It is 1 over x. Hopefully you can see that I realize I have a machine that's built of these parts, and I'm going to collect these parts methodically, and then I'm going to plug them into this machine. So that's my intention now, is to say that f prime at x is equal to f of x, which is 2x, times the derivative of the second function, which is 1 over x, plus the second function, which is ln x, times the derivative of the first function, which is 2. Right? So I'm just going to continue my algebra with you, if you don't mind. End up with 2x over x, right? Plus 2 ln x. I would not leave this 2 out here by the argument for fear that some lazy grader might think that you are adding this into the argument, which I know that you are not. X over x is 1, so we have f prime at x is 2 plus 2 ln x. I don't know what your teachers or professors are like. We could always factor out a 2 and get f prime at x is equal to 2 times 1 plus ln X. I don't know what sticklers they are for convention, but that's where we are. So what do we get from all this talk tonight? Hopefully we got this, that we start with the question as we look at a calculus problem, as we look at an application, we start with the problem, what's the best tool to use? What's the best tool to use? When we decide to use product rule, hopefully what we're saying is that we have two functions being multiplied. We have this scenario right here. We have two functions being multiplied, and it can't be simplified. And if we realize it can't be simplified, please consider the product rule. So I won't bug you anymore. I apologize for the sermon, but thanks for watching the video. If you have questions or comments, please let me know. And if you haven't already subscribed, please subscribe. Thanks, you guys.